Chapter 4, Chemical Bonding. So in Chapter 4, we will go through in this lecture C1 and C2 only. So this is the overview of Chapter 4, Chemical Bonding. So the first part, we will learn about Lewis structure. So in the end of this lesson, you should be able to write the Lewis dot symbol of an atom, state the octet rule and describe how the atom obtained the octet configuration, and describe the formation of the three bonds. So ionic bond, covalent bond, and dative bond. Lewis dot symbol. What is Lewis dot symbol? So Lewis dot symbol is the symbol that contain chemical element symbol to represent the inner shell, together with dot or cross placed around the symbol to represent the valence electron. So what is valence electron? Valence electron is the electron that stay in the outermost shell. So the highest quantum number. Highest n. Okay. So the example, sodium. So sodium, you have 11 electron. Okay, if you draw the electronic configuration, it will be 1s2, 2s2, 2p6, 3s1. So if I ask you how many valence electron, just take a look at the highest quantum number n. So what is highest quantum number? N equal to 3. Okay, so 1, 2, 3, you have 3 as the highest number. So how many electron? Electron, you can see on the top of the alphabet. So how many electron in the shell equal to 3? 1 only. So if you have 1 electron, you just represent the valence electron using the dot symbol. So if 1 electron, just 1 dot. Okay. Relationship between group and valence electron. Usually the group number represent the number of valence electron. For example, group 1, you have 1 valence electron. Group 2, you have 2 valence electron. Okay. Group 13 until 18, we ignore the 10 in front. Okay. So if you have atom or element in group 13, you just take the last number. So it will be 3 valence electron. If you have element from group 14, it means 4 valence electron, and so on. How to write the Lewis dot symbol? So for example, given to you nitrogen. So nitrogen has total 7 electron. Okay, total 7 electron. So write down the electronic configuration. So the electronic configuration would be 1s2, 2s2, 2p3. Okay. Outermost shell, and the highest quantum number is 2. Okay, so 1 and 2 only exist. So the highest number would be 2. So highlight all the quantum number equal to 2 and total up the number of electron on top of the alphabet. So 2 plus 3, it will be 5 valence electron. Okay, so you have 5 valence electron, and you can draw like this. This is the Lewis dot symbol for nitrogen. Let's start drawing Lewis dot symbol for nitrogen, for example. Okay, so starting with drawing the symbol of atom N. Okay, so you have 4 sides of nitrogen. So you have top, bottom, left and right. So first, you have to put a single dot on each side first. Okay, so nitrogen, you have 5 valence electron. You want to put it. So if I want to use cross, okay, so I just put 1, 2, 3, 4. Okay, so each side now has 1 electron. Okay, now we can pair the electron. Okay, so if you want to put it as dot, you can put it like this. So if you want to put as cross, also is not wrong. Alright. Okay, so Lewis dot symbol do not show the electronic configuration. So it just shows the total number of valence only. So if you have 3 dots, it means 3 valence electron. And let me remind you again, you cannot pair the electron first. So you must put them singly on each side. If all 4 sides of atom already occupied, then you can pair up. So this is the correct one. So this is the wrong one. So Lewis dot symbol of element in the same group will have similar valence electrons. So if element come from group 1, all of them will have 1 valence electron. Element from group 2 will have 2 valence electron, and so on. So they will have quite similar Lewis dot symbol. So the only difference is the atom. So for example, beryllium and magnesium, both of them will have 2 valence electron, but the only difference is the symbol of atom. The position of electron is just the same. Octet rule. Okay, so octet, you know octet means 8, number 8. Rule is rule. So this is the 8 rule. Atom other than hydrogen will tend to form a bond by losing or gaining or sharing of electron. Why they lose, why they gain, why they share? Because they want to achieve this octet rule. Okay, they want to get 8 electrons around them. Okay, other than hydrogen. Hydrogen only want to obey duplet. So hydrogen duplet rule. Okay, hydrogen can only take 2 electrons. Okay, other than hydrogen, they want to have 8 electrons. So this is what you call as octet rule. Losing, usually involving metal atom. Okay, metal atom usually coming from group 1 or group 2. Gaining electron, usually involving non-metal side. Okay, so non-metal. What about sharing? Sharing usually only involve non-metal only. Okay, there are exceptions for sharing. Okay, so the first one, octet rule. Atom may lose or gain or share electron to form stable ion, which obey octet or duplet for hydrogen. Why they want to obey the octet rule? Because when they achieve 8 electron, meaning that their valence shell will have ns2 and p6, meaning that if your valence shell equal to 3, 3s2, 3p6, the configuration would be like that. This electronic configuration is what we call as the maximum stability. So we said it has noble gas configuration. Okay, noble gas configuration. So if they gain or lose electron, their electronic configuration, we say that the electronic configuration of that atom is isoelectronic with a noble gas. Okay. So for example, Na metal tendency to lose electron. So how many electron it have? 1. So how many electron it will lose? 1. So when it lose electron, it will form positive charge Na plus. If you lose 1 electron, if you lose 2 electron, you will get 2 plus charge. Okay. Nitrogen, it has 5 electron. So nitrogen come from non-metal group. So non-metal tendency to gain electron or share electron. Okay, so how many more? 3 electron, it will gain. Okay, when it gain 3 electron, meaning that it receive negative charge from the electron. So how many electron it get? 3, meaning that the charge would be 3 minus. So the charge would be 3 minus, according to the number of electron it gain. So same thing with Cl. Cl, you have 7 electron, so it will need 1 more electron. So when 1 more electron is added, it will become -1 charge, so Cl1 minus.